already discussed rule of inference for propositional logic like modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, addition, simplification, conjunction, and resolution. Also, I discussed rule of inference for quantifier like universal instantiation, universal generalization, existential instantiation, existential generalization. In previous lecture, I discussed two examples, example 9 and example 10, where we used both rule of inference for propositional logic and quantifier. Let's combine rule of inference for propositional and quantified statement. Universal instantiation and modus ponens are used together. So this combination sometimes called as universal modus ponens. So universal instantiation means if for all P of x is true, then P of A is true. That is universal instantiation means if for all it is true, for particular A it is true. And modus ponens is if P implies Q is true, P is true, then Q must be true. As in case of implication, true implies false is false. As this is true, so Q must be true. Now we'll combine these two, that's called as universal modus ponens. For all x, P of x implies Q of x, then P of A, where A is a particular element in the domain, then Q of A is true. So combine both universal instantiation and modus ponens. So according to universal instantiation, for all x, P of x implies Q of x, then from this we can derive P of A implies Q of A. This is universal instantiation. Now if P of A implies Q of A is true and P of A is true, then Q of A will be true. Now we combine these two. So we combine modus ponens and universal instantiation. So it's called as universal modus ponens. In the same way, we can also combine universal instantiation with modus tollens. That's called as universal modus tollens. Like for all x, P of x implies Q of x is true. So from this we can derive P of A implies Q of A. So this is universal instantiation. And negation of Q of A is true. Negation of Q of A is true means Q of A is false. So when Q of A is false, P of A will also be false. Means negation of P of A will be true. So this is modus tollens and the above part is universal instantiation. Now we are combining these two, universal instantiation and modus tollens. So it's called as universal modus tollens. So for all x, P of x implies Q of x. The negation of Q of A, where A is a particular element in the domain, the negation of P of A. Let's see one example, example 11. Assume that for all positive integer n, if n is greater than 4, then n square is less than 2 power n is true. Use universal modus ponens to show that 100 power 2 less than 2 power 100. So let's P of n denote n greater than 4 and Q of n denote n square less than 2 power n. Now for all x, P of n implies Q of n, where domain consists of all positive number. So if n greater than 4, then n square should be less than 2 power n. P of 100 is true as 100 is greater than 4. Now for all n, P of n implies Q of n is true, P of 100 is true. We can apply the universal modus ponens, so Q of 100 will also be true. That means 100 square is less than 2 power 100. This is all about rule of inference. I discussed rule of inference for propositional logic and quantifier We can combine rule of inference for propositions and quantified statement. In next lecture, I will discuss introduction to proof. If today lecture is helpful for you, please like, share and subscribe. Thank you.